Hi, I'd like to look at finding outliers using Tukey's method. And here's a data set. They asked 20 New Yorkers how long it took them to commute to work this morning, and here are the responses they got. So if we're going to find outliers according to Tukey's method, the first thing I need to do is find the 5-number summary. Now we can find this by hand, by organizing these numbers and finding the median and finding the quartiles. Another way is to use the TI to do it. And I'll show you one method. You could use one of our stats, but I'm going to show you a method with a graph. So I've already typed this data into my L1, and I'm going to press second stat plot, go to plot number 1, and I want to make it a box plot of L1. The graph is on. It's a box plot of L1, and to graph it, I press zoom 9. Now there's my graph, but when I hit trace, it'll give me the 5 numbers in the 5-number summary right down here. So if I pull that graph over there, I see the median is 22.5. This is 15. Let's see, there we go, 15, 22.5. And I can find all these points. That's 5. That's 42.5. And then this big number up here is 85. So what I want to know is 85 an outlier? Or are there any other outliers? And I want to show the work to get this done. So the first thing I have to do is find the IQR. And the IQR is Q3 minus Q1. Q3 minus Q1. And so that's 42.5 minus 15. And you're welcome, of course, to use your calculator on that to get the answer. So I've got 42.5 minus 15. That is my IQR. Now to use Tukey's rule, he took 1.5 times IQR. So that's 27.5 times 1.5. And that's 41.25. Now what Tukey's thought is if you went 41.25 above Q3 and below Q1, you could find some boundaries after which you would get what he defined as outliers. So I want to take Q1 and I want to subtract that number, and I want to take Q3 and I want to add that number. And so that's 15 minus 41.25, and this is 42.5 plus 41.25. And so again, you could, of course, use your calculator to figure these out. It's 15 minus 41.25 and 42.5 plus 41.25. And these are my boundaries, if you will, negative 26.25 and 83.75. So nobody went less than that number, of course. So I have no outliers in the negative direction. But in the positive direction, I do have one number bigger than that. So there are no outliers in the negative direction. But since 85 is bigger than 83.75, I have one outlier in the positive direction. And I can verify this by using a modified box plot on my calculator. So I'm going to go back to this. I'm going to go back to my stat plots. I want to make a modified box plot right here. Press zoom 9 and I get this graph. I'm going to just lay this on top of this one. And you see we've got the same graph, except now they've pointed out that this guy's an outlier. Now I want to talk about a couple of parts of this real quick. Of course, the minimum, the Q1, the median, and the Q3 are all the same, This is still the max. So this number right here is the biggest number in the data set that's not an outlier. Let me say that again. It's the biggest number in the data set that's not an outlier. If I press trace on my calculator, it just calls this point X. X is 65. This other point's still the maximum. That 85 is still a max, even though it's an outlier. But that 65, this number right here, is the biggest point in the data set that's not an outlier. Notice this. These fences, these boundary points, don't show up on that modified box plot. So this is how you go through and use Tukey's method to find if there's an outlier in a set of data.